Hi again, everybody. This is Joseph. I'd like to thank the comments from people regarding the videos. Much appreciated. I was asked to give some feedback about symbols, popular symbols. This is a book that I have about symbols, and when it comes to automotive, many of the symbols are used repeatedly all the time. As some of the popular ones are antennas if you're doing radios in cars. The most important ones, I'll point them out, obviously batteries. And when it comes to battery, the small bar over here is the negative. The bigger line over here is the positive. So always remember polarity. You can have obviously cells together, like in your car battery, you have 6 cells in series together. Each one, it's 2.1 volts times 6 is 12.6 volts. Bells, not used that much. Buzzers, not used that much. Capacitors, not used that much, even though they are in timing circuits for your defroster, for the wiper blades. As timing circuits, they are part of. So they're in a module. You don't really have to be concerned about that. Ground, you have to be concerned with. Connectors, you have to be concerned with. Over here, as you can see, diodes, they are in the alternator. Alternator is an AC generator, but obviously we need something called DC to recharge the battery. That's where diodes come in, and diodes are in the alternator. They change the AC to DC. And many times you'll see something called this, a full wave or a bridge rectifier. But again, you don't have to worry about these things. These things, obviously, AC, they come a lot. See, these are non-polarized. These are polarized. See the small one, the big one. For receptacles, 120 volts. I'll point out the ones that really you have to know. You don't have to worry about diodes. These are LEDs. You don't really have to worry about it. Fuses, obviously, the fuse, the symbol. This could be also a fuse. As you can see, a chassis ground and an earth ground. You have to know that. Headphones, you don't have to know about. Inductors. All over automotive electronics, they're usually in the modules. Again, these are some are used, some are not used. And I have another one that I'll put on more information about. Microphones, motors are all over. Plugs, all over. Obviously the female, this is the male. Resistors used all over. Relay used all over. And if you want to know how relays work, you could go to my channel, Joe Electronic Schematics from Auto. When you see this, it means it's fixed value. Let's say it's 100K. When you see this, you see these type of things, that means it could be changed. It's not set. It could be 100 ohms to 200 ohms to 300 ohms. You can change the value. It does not have a set value. And speakers, we just did a video about speakers. Switches, very important. You have to know switches. Your ignition switch, everything. It could be run, access, start, have to know. This means they are all ganged together. When I move this one, I move this one, I move this one simultaneously at the same time. Have to know how switches work. And again, this on my channel. Okay. Transformers. Not used that much. Obviously transistors not used that much. This is for, and this is for, resistors are for students when they used to use through hole. Now we use surface mount. But on power supply boards, where there are power supplies, you still use through hole. You still use electrolytic capacitors. Remember that. So therefore, this is the code for it. And I have another book with more symbols. This is just a general view. Okay? Now, to go over a topic one time that I probably went over, but I'll go over it again because there's some confusion. Schematics are a challenge. However, I'm going to go back to the essentials, to the basics of electronics. This is a truth table that I put together. These are the points. 1, 2, 3, 4, 5, 6. The points that I labeled. 1, 2, 3, 4, 5, 6. So you can have more understanding what I'm referring to. F1 is the basic, we just said, a symbol for a fuse. S1 is a symbol for a switch. You can see this one, it's closed. If this would be open, you would see this straight line up, more up, leaving an air gap. And L1, and this one is a bulb, a filament. Could be a bulb in your car, anything. Could be a bulb for check engine light, anything on the dashboard, any light. Doesn't matter. This is referred to as the load. Now, let's say this is your car battery. We just said we use the symbol. Let's use the symbols that we just went through. A bigger one, line, a smaller, bigger, and a line. These are in series. These are cells together. The longer one is the positive. The smaller one is the negative. We just use this symbol. This is ground. Okay? Fuse is always indicated by F, the letter F, F1, F2, F3. Switches are always S, S1, S2, S3, S4. In between are the connecting wires. So in other words, you make a connection from the positive of this battery to one side of the fuse. Now you go to the other side. Remember that, not the same side, the other side. You make a connection from the other side of F1 to one side of a switch. Make a connection from here to here. There could be 3 wires, there could be 4 wires, as long as there is a connection. However, you don't use 4 or 5 wires. You try to use 1 wire. The less wires you have, the better it is, right? To trace it. Now, from one side of this terminal of S1, the other side of this terminal S1 goes to the bulb, the filament, the load in this case. The load is the one that's getting the current, the voltage. So load is L. So we abbreviated L1, L2, L3. So one side of F1, on the other side of F1, which is 2, goes to one side of S1. The other side of S1 needs a connection from here to one side of the bulb. The other side of the bulb goes to ground. Now, current flows in a circuit. It needs a complete path. This is connected to this. The fact that you don't see a line going from here to here doesn't mean it's not connected. However, we abbreviate it by putting a ground here, and this is ground. That means this is connected to this. Excuse me. This is connected to this. You don't have to draw a line. It's understood. And which one does this go to? The negative part of the battery. Ground goes to the negative. Now, current will flow through the fuse. Current is the flow of electrons. When often I always refer to, in automotive schematics, I always refer to current. And there's a reason for that. Voltage is the potential between two points. In other words, between this point as being my reference, I will put my negative here, and I will just change my positive lead and go here. I will keep my negative here, and I will put my positive here. I will put my positive here, keep my negative here. With reference to this ground, to this point, this is what I'm measuring. 12 volts, 12 volts, 12 volts. I can also take my voltmeter and measure across. I can't do that. I could take the positive here, put the negative here. I could take the positive here and take the negative here. But that is too tedious, and the easiest way to do it, you leave it one lead as a negative, just like in automotive. You always leave the lead to ground, and you move around the positive. So this is the positive lead, right? I move the positive here. I move the positive here, the positive here, positive here, positive here, until I get to the point that I want to measure my voltage. I measure 12 volts here. Why? Because this is connected to the battery. It's just a wire. There is no loss. What do I mean by no loss? No loss means low resistance. Now, from 1 to 2, I have 12 volts here, 12 volts here. Why do I have 12 volts here? Because again, there is low ohms here, low resistance. I have no voltage drop. Voltage drop means a difference of voltage between 2 points. So this point to this point, I have very low voltage, maybe 0.1, 0.2. Doesn't matter. 12 volts here, 12 volts here. Through a conductor, we don't lose any voltage either. Right? It's just a piece of wire. Again, if I measure here at, I call this 0.3, I measure 12 volts. Why? Again, we didn't lose any voltage going from the battery till here. So this is 12 volts. Again, 0.4, as I designated it. What should I measure? 12 volts. Why? Again, no loss on S1. It's just a switch. It's like a piece of jumper wire that has no resistance. When I have a lot of resistance, I lose voltage across it. No reason to lose voltage. It's like I have a wire going directly to the battery. From 4, we go to 5. Should I lose any voltage? No, it's just a piece of wire. I measure 12 volts here. I should measure 12 volts here. Here is where we lose the voltage across the load, and that's why you call it a load. 12 volts here, 0 volts here. Why is this 0? Because with respect to ground, this is 0 volts. 0 volts. But with respect to ground, at this point, I lose 12 volts across the whole load. So all of the voltage is going across this filament, this bulb. That's why it's referred to as the load. When you plug in your refrigerator, that's the load to the AC outlet. So 12 volts here, 0 volts. How much is across here? Subtract. 12 volts minus 0 is 12 volts. I lose the whole 12 volts across this. I hope you understood that. Time to troubleshoot. I did a chart over here regarding if component failures happen, as it does many times in automotive. And I think this is much needed for the viewers. Seeing the responses that I get, schematics, it's a skill and it's a dedication that you really have to work on it very, very hard. And to be good at it, you have to know first the symbols. You have to know what the symbols do. You have to know what the components do. And that comes from trial and error and just going over it again and again and again. And this is the most simplest circuit that I could come up with from a book that I used to study. F1 open. I put in a fault. F1 open. If F1 is open, this is out of the circuit. This one is out of the circuit. How much should I measure here? Remember the rule. If I'm connected to the battery, if I'm still connected to the battery, I'm still going to measure 12 volts. What do I go at pin 1? 0.1. 12 volts. The rest of it will be 0 volts. Why? I'm connected to the battery. Now this is open. It's like this wire is not here. Therefore, this will measure 0. Why? Because there's no connection through this fuse to the battery. What will I measure all afterwards? 0. If this is 0, this is 0. 0, 0. Why? Because these are not connected through the battery. Basically, 12 volts here, 0 volts here. Across the open, I measure the whole 12 volts. Remember that. So 12 volts here, 0 volts here. I measure the whole 12 volts. It's like this being the load. Because this is connected to the load, to the battery, and this is not connected to the battery. Open is very high ohms. Therefore, 12 volts here, 0 volts here. The rest is 0, as you can see from the truth table. Let's take another faulty component in automotive. S1 has a problem. Right? I close the switch in the car, to try to illuminate the light inside, the cargo light, anything, the glove compartment light. It doesn't go on, right? I look at the light, I close the switch, I say, okay, where's the cargo light? Where's the dome light? It's not lighting. Okay, is it the switch? Is it the bulb? Is it the fuse? Let's do fundamentals of troubleshooting. And what we just learned, let's apply what we just learned. This is good. This is intact. F1 is good. S1 is the problem, is open. What will I measure? What will I measure from here? F1 is still connected to the battery, correct? I'll measure 12 volts. Through the battery, I'll measure the other side. What should I measure? 12 volts. Why? I'm still connected to the battery. The fuse is intact. At 3, what do I measure? 12 volts. Why? I'm still connected to the battery, like a jumper, there's a jumper here, and I'm measuring the battery. 12 volts. What should I measure here if this is open? 0 volts. Why? Because I'm not connected to the battery anymore. As you can see over here, 4 is 0. 12 volts, 12 volts, 12 volts, I'm connected to the battery. Right? If you apply Ohm's law, 12 volts, 12 volts, I have 0 volts across this, 12 volts here, and 0 volts, 0 volts, 12 volts across here. This has all the high resistance. And therefore, I'm not connected at this point to the battery. Therefore, I know if I measure 12 volts here, I'm connected. I measure 0 volts here, I am not connected. That means this in between these 2 points, I lost the connection to the battery, and this is open, which it is. I hope you understand that. Therefore, afterwards, anything afterwards is also 0. 0, 0, 0. This is always 0. It's ground. I hope you can understand that. Okay? Try to absorb that. Next, L1. L1. Now, L1 is open. How much should I measure? If you look at the truth table, 1, 2, 3, 4, 5. It almost looks like it's actually working, the circuit. And I'll explain and elaborate. 12 volts here. This is intact. This is good. This component is good. This component is not good. It's open. Right? You went to turn on the light, and the light didn't work in your car. 12 volts here, 12 volts here. Why? This fuse is still connected to the battery. 12 volts here, 12 volts here. Why? This is still connected to the battery. Come over here. 12 volts. Why? It's still connected to the battery. Excuse me. I come over here. 12 volts. And I come over here, 0 volts. Oh. But didn't we just say that we measure 12 volts across the load when it's good? But now this is open. Why am I measuring 12 volts? Because I'm still connected here through the battery. The fact that this doesn't glow, when I go to troubleshoot and I measure 12 volts across here, 12 volts across here, tells me I'm connected. This must be good. This must be good. I'm connected here. The only thing that's left is this bulb as being bad. Why? Because it's not turned on. It's not illuminated. See all these things going up, showing illumination. It's not illuminated. So bad or good. If it's good, I'll measure 12 volts because the whole load takes the 12 volts. If it's not good, I'm still connected to the battery. It's like I have a jumper wire going directly to the battery through this, and I'm measuring the battery from this point. I'm going to measure 12 volts. Right? And I measure 0 volts over here because this is going to ground. I'm not going to measure 12 volts here, 12 volts here. This is ground. I'm going to measure 12 volts across the whole thing, which tells me I'm losing the whole thing, but also this must be open. A little confusing, but you have to understand how the circuit works. Again, if I measure 12 volts at any point, 12, that means I'm connected to the battery. That's good. If I lose 12 volts, if this is 0 volts, 0, I am not connected to the battery. Anyway, please subscribe to my channel. Automotive Electronic Schematics by Joseph, and the other one, Joe, Electronic Schematics from Auto. I thank you for the comments. Please, maybe if you could recommend it to your friends, and I would appreciate it to tune into the channel. I would appreciate it. Thank you for your comments. Hope this helped a little. Thank you.